Hello, geometry students. Welcome to the notes for section 1.3, midpoint and midpoint formula. Today's I can statements are as follows. I can recall understandings of coordinate geometry, including midpoint and distance formulas. I can perform and explain the construction of geometric figures using a variety of tools and methods, aka midpoint and bisector. And I can identify and use properties of midpoint to determine segment lengths and endpoints. So before we get started, we need to cover what bisect means. Bisect is when you divide something into two equal parts. Divide into two equal parts. And it's important that we know what bisecting is, because every time you see that in geometry, you're going to have to think two equal parts. Two equal parts. So now you can pause the video, copy down the definitions for midpoint and segment bisector as they are in the table below, and then we're going to talk through what these look like in a picture. Okay, so midpoint is the point that divides a segment into two congruent segments. So what that's going to look like as a picture is you're going to have a line segment. Line segments have endpoints, and typically we're going to name them. So say I had line segment EG. There is a point halfway between those two. I could call that F. And in this example, F is going to be the midpoint. F is the midpoint because the distance from E to F is the same as the distance from F to G. So if these are the same length, which is what those little dashes mean, that would mean that F is the midpoint. Then we can look at segment bisector, a point, ray, line segment, or plane that intersects the segment at its midpoint. So this is going to look very similar to the figure that I just drew, but it's going to have one key difference. So say I have a line segment with a midpoint, so we can have A, B, and C, where B is the midpoint because AB and BC are congruent segments. Sometimes, instead of just having a point, you can have a different thing. So a point, ray, line segment, or plane that bisects the segment. So if you look at the line that I just drew, and I could call that line N, you would say that line N is the segment bisector. Line N is the segment bisector. And so instead of just having a midpoint, we have a segment bisector because it's a whole line that is going through halfway between line segment A and C. So I have a couple examples. It says, determine which of the following shows a midpoint and justify your answer. And so we're just going to look through these and think to ourselves, okay, do I have a line segment? Do I have a line segment that is broken up into two equal parts? If I do, then you would have a midpoint. So if we look at example A, we can assume that this is not drawn to scale, but if you look, this segment is significantly shorter than this segment. Okay, if I wanted to know that these two were congruent, they would have to have some sort of mark or some sort of distance labeled. So this is not going to have a midpoint because the segment is not broken up evenly. Typically, I'd say don't trust the picture, but on these ones, you have to look at the picture and trust it. On B, you notice that these two line segments are the same length. However, they are not on the same line segment total. So for me to have a midpoint, this would have to be a line segment that was all one, like all one line segment broken into two even parts. Instead, I have two evenly lengthed, is that a word? line segments, but it does not bisect a larger line segment. They just happen to be connected at that point. So these are actually two completely separate segments. And if you're looking for an explicit answer to determine which of the following shows the midpoint, I mean, it's not A, it's not B, based on what we just discussed. So the answer is going to be C. The reason I know that is because I have one larger line segment. I am told that I have two lengths that are the same. Okay. So that means the segment on the left and the segment on the right are congruent. So I do have a midpoint. And a lot of that just comes back to looking at the definition and figuring out, okay, does this fit the definition or not? Now, we can also use this information to answer questions about different diagrams. So in example 1, it says identify the midpoint and segment bisector of line segment PQ, then find PQ. Okay, so if we look at this graph, we know a couple things, or this diagram. We know that PM is 1 inch and 7/8. M is the bisector, so that means MQ is going to be the same length, 1 inch and 7/8. So the midpoint is point M. The segment bisector is going to be this right here. And this is actually something we're going to talk about more in the future, but you've probably seen it before. This is actually called a ray. And with a ray, you start with the point that is not close to the arrow, and then you go to the point that is close to the arrow. So MN, ray MN, is going to be our segment bisector. Then you can figure out what the total distance of PQ is. So PQ, the length of PQ, so I'm not going to write a line segment over it because I'm doing the length, so it's just letters PQ. It's going to be 1 and 7/8 plus 1 and 7/8. So that's going to give me 2 and 14/8. But since we're doing mixed numbers, 14/8 needs to be simplified. So it's like we have 2 and, let's see, 1 and 6/8. So 2 plus 1 gives me 3, and then 6/8 gives me 3/4. So that's just adding with mixed numbers practice, something you probably haven't seen in a while. But again, 1 plus 7/8 and 1 plus 7/8 gives me 2 and 14/8. 14/8 as a mixed number is 1 and 6/8. So then I can add that to the 2 I had before, and I got 3 and 3/4. You also could do those in a calculator, do it as a decimal approximation. I'm not going to be super picky. One way that I can make these questions a little bit harder is if I introduce variables. So if we look at example B, again, I have a midpoint, I have a segment bisector. My midpoint on this one is M, because that's what cuts the line segment PQ exactly in half. And then the segment bisector is going to be line L. You can see it is labeled. So I have line L. And I'm making it curly. And I need to figure out what PQ is. So the first thing I have to do before I even try to find PQ is I have to figure out what X equals. The way that I'm going to figure out what x equals is I'm going to figure out what things have to be equal to each other. And what's nice is we have a segment bisector. So that means that PM and MQ are congruent. So what I can do is I can say, okay, if those line segments are congruent, I know that their lengths are equal to each other. And what that's going to allow me to do is I can solve for my x value, and then I'm going to be able to solve for PQ. So I need to solve this equation. I want to move variables to one side, so I'm going to move all of my x's to the left by subtracting 2x from both sides. I get 3x minus 7 equals 11. Then I want to move all of my constants or my plain numbers to the right side, so I'm going to add 7 to both sides. I get that 3x equals 18. And then lastly, I need to solve for x. The way that I'm going to get x alone is I'm going to divide both sides by 3, and I get that x equals 6. So I've solved for my x value. That is going to allow me to figure out this distance. So I'm going to have 5 times 6 minus 7, 30 minus 7, or 23. So this distance is 23. That means this distance has to be 23. So PQ, the length of PQ, is going to be 46 total. Guys, that was a challenging problem. So if you're sitting there freaking out a little bit, that was a challenging problem. They are not all going to be that tricky. But you do want to get in your head, what can I set equal to each other? Because you're going to have to set a lot of things equal to each other in this unit. And that's why we practice solving equations earlier. If you need more time, you're welcome to pause the video. Otherwise, I'm going to go on to example number 2. In example number 2, line L bisects line segment HJ at W. Find the value of x and the length of all 3 segments. So we are given a picture, and then we are also given these values in the bottom left corner of the page. I am told that HW is 3x, and I'm told that WJ is 5x minus 10. Ultimately, our objective is to find the value of x and the length of all 3 segments. So we must stop and think to ourselves, okay, if I'm going to find x, I need to have something that I can set equal to something else. And in that way, we're going to use the information that these are bisectors, because that means that the length of HW and the length of JW are going to be the same. So we can set them equal to each other, and that's going to let us solve for x. So I have 3x equals 5x minus 10, and I'm going to be able to solve for x. So I want to get all my variables on one side. I'm going to subtract 5x from both sides to move everything to the left. So I get negative 2x equals negative 10. And then I'm going to divide both sides by negative 2 to get x completely alone. So I get that x equals positive 5. So already I have answered the first question. Find the value of x. Then you can take the value of x and you can figure out the lengths of the different segments. So HW is going to be 3 times x, or 15. I know that WJ is the same length, so that one's also going to be 15. And then if I wanted to say the length of the total segment, the one that was bisected, the total distance would be 30 because it's 15 plus 15. So that's a bit of a crash course as we've talked about midpoint and segment bisectors. And that also gives you an example of how you're going to set different aspects of the diagram equal to each other to find variables, and then use the variables to find different lengths. All right, let's move on to the back. So on the back, I have another definition that I want you to write. It says, this is the equation we can use to help us calculate the midpoint of a segment in the coordinate plane. So this is a key concept. If A, so that's a point with coordinates x1 and y1, and B, another point with coordinates x2 and y2, so if you have 2 points, then the midpoint of line segment AB has coordinates, and it would be called point M. And what you do is you take the x values, add them together, and divide them by 2, and that's going to give you your new x value. You take your y values, add them together, and divide it by 2, and that's going to give you your new y value. So basically, you're taking the x values you were given, and you are finding the average of each of them. Now, if I gave you a graph, here's what it would look like. Say you had a point at 4, 3, and you had another point at 0, -1. Say these were point A and point B of a line segment. If you wanted to find the midpoint, so halfway between those two, what you would do is you would look at the x values of A and B, and you would average them. You'd find the x values of A and B, and you would average them. You would also find the the y values of A and B, and you would average those too. And what that's going to do is it's going to find the midpoint of the line segment. Conceptually, seems a little crazy, but in practice, it's actually not that bad. So again, this is just taking what we learned about midpoint at the top and saying, how can you find a midpoint if you are told to graph some points? So let's do an example. Example 3, the endpoints of line segment DT are 1, 2, and DT are 1, 2, which is point D, and 7, 8, which is point T. So first I'm going to put those on the graph. D is at point 1, 2, and you're going to want to go ahead and just label them, keep everything organized. And then T is at 7, 8. So right 7, up 8. That's point T. And we are told to find the midpoint of this line segment. So what we can do is we can take those 2 points and we can use the formula. So if I have point 1, 2, and I have point 7, 8, I can go through and label these as x1, y1, x2, y2, because they're the 2 points I have. And then we're going to be able to figure out the midpoint. So the midpoint, or M, is the ordered pair that you get once you simplify x1 plus x2. So you're going to add up the x values and divide it by 2. And then y1 plus y2. So you add up the y values and divide them by 2. Okay, I know it seems like a lot of writing and it looks kind of weird, but you're going to get the process down. So you take the given x's, add them together, divide it by 2. You take the given y's, add them together, and divide it by 2. And then you want to simplify. So 1 plus 7 is 8 over 2. 2 plus 8 is 10 over 2. Last step to simplify, 8 divided by 2 gives me 4, and 10 divided by 2 gives me 5. So according to my math, the midpoint for line segment DT should be the ordered pair 4, 5. What's nice is if you put that on the graph and label it M, visually you should be able to tell if that is the correct midpoint, and it totally is on this graph. So I always suggest you check on the graph. It's an easy way to make sure you're going to get full credit. Now, we do need to be careful when we're reading these because I might throw you a curveball, which is what happens in the second example. So notice in that first example, and let me make this a little wider, I gave you the 2 endpoints. But let's look what's going on in example number 4. The midpoint of line segment DG is point O at -1, -2. So let's make sure we're doing that correctly on the graph. The point -1, -2 is the midpoint. That's the midpoint. It's called point O, so it's the midpoint. One of the endpoints is point D, located at 4, 4. So 4, 4, which is about here, is one of the endpoints. So what I need to do is I need to be very careful looking at this graph and say, okay, I have an endpoint, I have a midpoint. How am I going to be able to find the other endpoint? Now, you could do this algebraically, but I'm going to be totally honest with you. I think these are easier if you just count them. So what I do is I look at the midpoint and I say, okay, well, how did I get from the midpoint to point D? And I look at this and I say, okay, I went up 1, 2, 3, 4, 5, 6, 7 units. I went right 1, 2, 3, 4, 5 units. So up 7, right 5. So if we do the opposite of that, if we go down 7, left 5, that should be the point that I want, right? Because it now made O the midpoint. All I did was I figured out how did I get from the midpoint to the endpoint, and then I went in the exact opposite direction and I counted the different squares to know how far to go. So that is my suggestion on how you do those type of problems, is you just kind of look the opposite direction and say, okay, I need to, instead of going up and to the right that distance, I'm going to go down and to the left that distance. It's also pretty similar to how we do slope. So then you can look at this point and count and say, okay, well, where did it end up being located? This is called point G. So point G is 1, 2, 3, 4, 5, 6 to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9 down. Actually, I think it's supposed to be 8 down. Sorry, my counting got a little out of control. There we go. And then that is going to be where my midpoint is. So G is located at the point -6, -8. Lastly, if you want to pause the video and go ahead and try to do example 5 on your own, that's my suggestion. I'm then going to go through and I will explain it. So for example E, and again, let's be careful in our reading. The endpoints of a segment are G, located at -7, 8, and O, located at 5, -4. Is the midpoint E at -2, 3? If yes, show graphically and algebraically. If no, explain and find the endpoint. So we have two endpoints, G, which is at -7, +8. So I'm going to go ahead and put that on my graph. It'll help if it's not in highlighter. Whoops. So it's going to be right here. That is point G. Then I'm going to put point O on my graph. So that's at 5, -4. So right 5, down 4, and that's point O. Go. So we are asked if point E is the midpoint, so -2, +3. And visually you can kind of tell maybe that it's not the midpoint. I can just see on that graph that it looks a little bit off center. But what I would like to do is take G and O, find their midpoint, and then we can compare and see if it's the same as point E. So here are my endpoints. Again, we're going to use the formula. So the formula for midpoint adds up the two x values and divides it by 2. adds up the two y values, and divides it by 2. Then you can simplify. So negative 7 plus 5 gives me negative 2 over 2. 8 plus negative 4, that's like having 8 minus 4. So it's going to give me 4 over 2. So when I finish simplifying, my midpoint is at the ordered pair negative 1, comma 2. Considering that point E is negative 2, comma 3, that means that E is not the midpoint. E is not the midpoint. Negative 1, 2 is. And if you see, if I put negative 1, 2 on the graph, it does look like it's right in the middle of those two line segments. So it's halfway between G and O. All right, so there you go. That was lesson 1.3. We're going to do some additional practice back in WebEx. Thanks for watching.